Hello, everybody, and welcome to this week's lesson. This week we are continuing to talk about two-dimensional geometry. We're going to be talking about polygons and compound figures. So this builds on top of our lesson in the last unit on two-dimensional geometry, where we talked about triangles, rectangles, and circles. We're basically going to be covering the other types of two-dimensional shapes that you might encounter on the GED test. We're going to get started with this warm-up problem here. And for this lesson, you want to make sure you have your welcome packet because we're going to be using your formula sheet, your GED math formula sheet that's inside of your welcome packet. You want a pencil and paper and a calculator. So this warm-up problem should hopefully seem familiar to you if you participated in the lesson last week and did your homework. It says a total of 64 feet of fence is required to enclose a square vegetable garden. What is the area of the garden? So we're talking about a square. That's a four-sided shape with four equal sides and four equal angles. It says 64 feet goes all the way around the garden, right? It's required to enclose, to go all the way around the outside of this garden. So that means we're talking about the perimeter of the garden, right? The perimeter is 64 feet. And we're asked to calculate the area. So this is a square, and we want to calculate the area. I'm going to check my formula sheet, and I see that the formula for area of a square is the side length squared. So we need to know the length of the side, the length of all four sides of this square. So how do we do that? Well, we take our total length around the outside and we divide it by our four equal sides. That tells us each side is 16 feet. So the length of one side is 16 feet. And now we're ready to calculate area. So it's going to be 16 feet times 16 feet, which is 256 square feet. All right, so our learning goals for this week. By the end of the week, you will be able to compute perimeter of a regular polygon. You'll use a formula to compute the area of a polygon. You'll determine side lengths of a shape when given perimeter or area. And you'll compute perimeter and area of 2D composite geometric figures using formulas as needed. So we're still using our formula sheet. We're thinking about perimeter, we're thinking about area. So we're going to talk about what's a polygon, and we're going to talk about what's a composite figure. So let's start with polygons. Last week, we started talking about plane figures. And we want to remember that a plane figure just means a flat or a two-dimensional shape. And a polygon is a type of plane figure. Some of the shapes we talked about last week are polygons. A polygon is a closed plane figure with straight sides. So last week we talked about rectangles, squares, parallelograms, trapezoids, triangles, rhombuses. Those are all examples of polygons. They are closed flat shapes with straight sides. The only shape we talked about last week that is not a polygon is a circle. So a circle doesn't have straight sides, so it's not a polygon. And up in the top right corner here, I have some examples of things that are not polygons. So we've got these three shapes here that are not polygons because their sides aren't straight. And then this fourth shape here is not a polygon because it is not closed. It has this opening right here. All right, and then down at the bottom, we can see that polygons are sometimes sorted into two different categories. So one of those categories is regular polygons. A regular polygon is a polygon with equal sides. And I have some examples of those here. So a square has four equal sides. You can have a triangle that has three equal sides. And then here we've got a shape with 5 equal sides. A shape with 5 sides is called a pentagon. And then with this shape, this last red shape here has 6 equal sides. A 6-sided shape is sometimes called a hexagon. And then if you have regular polygons, that means you can also have irregular polygons. Irregular polygons have sides of different lengths. So a rectangle is another example of an irregular polygon, right? It's got the long sides and then the shorter sides, so different lengths. All right, so let's practice calculating perimeter of regular polygons. And to do that, we want to remember what perimeter means, right? Perimeter means the distance around the outside of a shape. So if we have a regular polygon, that means all of the sides are the same. When I look at this purple shape here, I see that it's got a total of 8 sides, which means it's an octagon. Stop signs are octagons. And only one side is labeled, so I can assume that all of the sides are the same. So if I have 8 sides and each side is 7.25 inches, that means in total, right, 8 times 7.25 will give me 58 inches all the way around this octagon. You could, if you wanted to, add up the sides, right? 7.25 plus 7.25 plus 7.25. You'd have to do it 8 times. The multiplication is a shortcut for that. All right, and then this yellow shape has 5 sides, so it's a pentagon. Only one of the sides is labeled, so we can assume that each side is the same. Each side is 4 centimeters. So I'm going to do 5 sides times 4 centimeters each. And that gives me a total of 20 centimeters all the way around this pentagon. So calculating the perimeter of regular polygons should be a fairly straightforward task, right? You are just adding up all of those sides. And since in the case of regular polygons, all the sides are the same, you can use multiplication as a little shortcut. All right, so now let's talk about area of some polygons that we haven't done yet. So last week, we talked about the different types of, some of the different types of two-dimensional shapes you might encounter on the GED test. You might be asked to calculate area of a square. We practiced doing that last week. We practiced area of a rectangle. We practiced area of triangles. And we practiced area of circles. And we did identify parallelograms and trapezoids, but we did not practice calculating their areas. So we are going to do that this week. So we're going to practice calculating the area of a parallelogram. And we're going to practice calculating the area of a trapezoid. So I've got 2 shapes on this page here. The first shape on the left, this is a parallelogram. It's a 4-sided shape, which we could call a quadrilateral. And it has 2 pairs of parallel sides. So a 4-sided shape with 2 pairs of parallel sides, that's what makes this a parallelogram. I'm asked to calculate the area. So I looked at my formula sheet. I see area is base times height. We want to remember that on a shape, the base and the height always meet each other at right angles. So the base and the height always meet at right angles. So that means for this parallelogram, the base is 15 inches and the height is 9 inches. We don't need to use that 10-inch measurement. That's just an extra piece of information for this problem. And 15 times 9 is 135, and that'll be square inches. All right, and then this next shape is a trapezoid. So a trapezoid is also a 4-sided shape. It's a quadrilateral. And it's a quadrilateral with one pair of parallel sides. So the parallelogram, right, the top and the bottom are parallel, and then the left and the right sides are parallel, right? Parallel meaning they go in the same direction. A trapezoid just has one pair of parallel sides. So in this case, it's the top and the bottom that are parallel. So I'm asked to calculate the area of a trapezoid. I look to my formula sheet and I see the formula is half times the height times the sum of the two bases. So it might sound kind of weird to have two bases, because how can you have like two bottoms of something? But in this case, the bases are the two parallel sides. So we have the bottom, we could call that base 1. And then we have the top, that's going to be base 2. And 15 will be our height because it's a line that touches our two bases at right angles. All right, so let's fill in these numbers here. The height is 15 feet. Base 1 is 31 feet, and base 2 is 13 feet. All right, so let's follow the order of operations here. So I'm going to take care of any operations that I have inside of parentheses first. And so that means I'm going to do my addition first. That's going to give me 44 feet. 31 plus 13 is 44. And now I just have multiplication left. So I have a half times 15 times 44. You can do this multiplication in whatever order is convenient to you. But when you do a half times 15, that'll give you 7.5. And then 7.5 times 44 will give you 330. So it's 330 square feet. All right, so next let's talk about composite or compound figures. These two words mean basically the same thing. So a compound figure is a shape that can be broken down into simpler shapes. Or you can think of it as taking simple shapes to build something more complicated. So compound, you can think of it as like complicated or complex because it's made up of smaller parts. So this first example here, this compound shape, it could be broken down into, you see that dotted line there, I've split it up into simpler shapes. We can split it up into a rectangle and a half circle, which is sometimes called a semi-circle. And this middle shape here kind of looks like maybe a factory or a drawing of a house with a chimney maybe. It can be broken up into two rectangles. So we've got this rectangle on top and this rectangle on the bottom. And then the third example here, this arrow, the arrow could be thought of as a rectangle stuck to a triangle. So you may be asked to calculate the perimeter or the area of these compound shapes. With perimeter, the idea is the same as it's always been. You're just adding up all of the sides of the shape. You might need to do a little calculating to figure out the lengths of different sides. We'll see that in a minute. Or you could be asked to calculate area. So if you're calculating the area of a compound shape, you're going to need to split it up into its simpler shapes, calculate the area of each simple shape, and then add up those areas to get the total amount. So again, we're going to see examples of that coming up next. All right, so we want to calculate the perimeter and the area of this blue shape here. Let's do the perimeter first. So perimeter just means adding up all of the sides. I look at my shape and I see there's actually a couple of sides that I don't know the measurements for. So I'm going to need to figure out those missing measurements first before I can add up all of the sides. When you are trying to figure out missing side lengths like this, you want to look to the sides that are parallel, the sides that are pointing in the same direction. So let's start with this vertical, the short vertical side here. Now you might look at that and go like, that looks like it's about half of 9. You don't want to estimate with your eyeballs. You want to use the numbers you've been given to do a calculation to get exactly the right answer. So that's why you need to look to the sides that are parallel. So we're going to look at this 9. Okay, this is also a vertical measurement. So that's telling us that the total height, right, from the bottom all the way to the top of this shape is 9 feet. And then we also have this vertical line right here. So you can maybe imagine if I bring these two vertical measurements over, so if I take this red line right here and I move it over to my mystery side, I would have this to this is 9 feet. And then if I take this 5-foot measurement and I move it on over, right, that would tell me that from here to here is 5 feet. So the missing chunk, the missing piece here has to be 4 feet, right? 5 feet and 4 feet altogether gives us that total amount of 9 feet. And then we can repeat the same process with the horizontal sides. So we've got this mystery horizontal side right here. So I'm going to look to the other horizontal measurements to help me out. I know that this shape all the way across is 11 feet. And then I know that this piece right here is 4 feet. And so that tells me that this missing chunk must be 7 feet. Okay, so now we have all of the sides filled in. We can add them all up together to get the perimeter. So 4 plus 4 plus 7 plus 5 plus 11 plus 9 all together. That gives us a total of 40 feet. So the perimeter of this compound shape is 40 feet. All right, so now let's tackle the area. So to calculate area, we're going to need to split this up into simpler shapes. There's a couple of different ways we can do that. We could extend this line down here to split it up into 2 rectangles. You could also split it up in a different way. You could bring a line across here to split it up into a square on top and then a rectangle on the bottom. You can do it either way you want. Both ways will bring you to the same answer. I'm going to split it up into 2 rectangles. So I'm going to call this rectangle 1 and rectangle 2. So the area of rectangle 1, formula for area of a rectangle is length times width. So rectangle 1 is going to be 9 times 4, which gives us an area of 36 square feet for that left-hand rectangle. And then the area of rectangle 2, again, same formula, length times width, and that is going to be 7 feet times 5 feet. You want to make sure you don't use that 11, right? Because the 11 includes part of rectangle 1. We don't want that. We're just talking about rectangle 2 right now. So 7 times 5, that gives me 35 square feet. And now I'm ready for the total area of this full shape. I'm just going to add up my 2 areas to get the total area. So 36 and 35. together give you 71 square feet. All right, let's take a look at another example here. So we've got a compound figure. We want to know the perimeter and the area. Let's start with perimeter. I take a look at my shape and I see that actually all of these sides are labeled. So I can go ahead and just start adding up these sides. So 5 plus 7 plus 6 plus 10 feet. All together, that is going to give me a total of 38 feet. So the perimeter of this shape is 38. So now we need to calculate area. To do that, we're going to need to split this up into shapes that we know how to calculate the area of. Let's bring this line across here so that we have a triangle and a rectangle. So the area of the triangle, the formula for area of a triangle, check your formula sheet. You'll see it is half of the base times the height. So that means for this triangle, we need to figure out the base and the height. Remember, the base and the height are the two sides or the two lines that touch each other at right angles or intersect at right angles. So this will be the base of the triangle and this will be the height. So we're going to need to figure out the height of the triangle and the base. We're going to look to the sides that are pointing in the same direction. So I know that the height of the whole shape altogether is 10 feet. And then I know that this piece here is 6 feet. So that means the height must be 4 feet. And then for the base, same idea. I know that this shape all the way across is 10 feet. I know that this part right here is 7 feet. And so the base must be 3 feet. All right, so I want half of 3 feet times 4 feet. So it's all multiplication. You can do it in whatever order you want. Let's do 3 times 4 is 12. And then half of that would give us 6 square feet. So that's the area of the triangle. Now let's do area of the rectangle. So formula for that is length times width. The rectangle is 10 feet long and the rectangle is 6 feet wide. And that gives you an area of 60 square feet. All right, so now let's do the total area, right? We know the area of the two parts, and so we're going to add our parts together. That gives us a total area of 60 square feet plus 6 square feet. 66 square feet is our total area. All right, so we're going to finish up this lesson with a few word problems. Number 1 says Rusty needs to order enough wood to fence in the community garden grounds, which are in the shape of a regular pentagon with 5 congruent sides. If the fencing costs $15 per foot, how much will it cost to fence in the community garden? And we have a picture here of the pentagon. And we've got some information about the side length here. So it's a regular pentagon, with 5 congruent sides. So what do you think congruent means if we know that this is a regular pentagon? So congruent means the same or equal. If our 5 sides are congruent, that means they all have the same measurement. So we want to fence in this community garden and figure out the cost of that fencing. First thing we're going to do, we're going to figure out how much fencing do we need. So we're gonna figure out the perimeter, the total distance all the way around. We look at our picture and we see one of the sides is 20 feet. So if I have 5 sides that are each 20 feet, all together, that is 100 feet of fencing that I need. Okay, and then it costs $15 per foot. So my total cost is going to be 100 feet times $15 per foot, which gives me a total cost of $1,500. So not a cheap project, but hopefully that's some good quality fencing that Rusty's buying. All right, number 2, find the missing value in the given trapezoid if its area is 45 square centimeters. So we know this is a trapezoid and we know the area. We're told the lengths of these 2 parallel sides here, the top and the bottom, and we're missing this side labeled X. So X is actually just another name for the height of this trapezoid. Remember, earlier when we talked about area of the trapezoid, we talked about how the height connects the 2 bases. Since this problem is talking about area of a trapezoid, right away, I'm going to go ahead and write down my formula. So the area is half times the height times the sum of the 2 bases. Now I'm going to fill in the information I know. So I know the area is 45. I'm going to replace A with 45. Do I know the height? No, I don't. That is the missing piece of information, right? So I'm actually going to move the height to the end here. And then we do know the 2 bases. We know the 2 parallel sides. So that's 10 plus 8. So I moved the h to the end here because when you're multiplying with variables, usually you write the variable last. So for example, if we were talking about multiplying x with 2, instead of writing x2, you would usually write 2x. It's just kind of a rule that people follow. And actually, since in this problem, the height is labeled x, I'm going to rewrite my equation here to use that letter x that I was given. Okay, so now we're going to do as much of these calculations as we can without knowing what x is. So I can go ahead and I can add those bases together to get 18. And then we want half of 18, which is 9. So 9 times some number x gives us 45. You might know that off the top of your head, but if you're not sure, to solve for x, you would divide. 45 divided by 9. That means that x is 5. So the height of our trapezoid is 5 centimeters. All right, on to number 3, our last problem here. The following shape is formed by attaching a square whose sides measure 6 meters to a semicircle whose diameter is 6 meters. What is the perimeter of the shape? Round your answer to the nearest tenth. So we've got a square, and then we got half a circle stuck on top of it. We want to find the perimeter. This is a perimeter type of question. So how do we find the perimeter of something? Well, we find the perimeter by adding up all of the sides, right? It's the distance around the outside of the shape. So we're going to do these 3 straight sides here. Since it's a square, I know each of these straight sides is 6 meters. I also know that this inner dotted line here is 6 meters. And that's actually going to be the diameter of this half circle that we're talking about, right? Because the circle is stuck to the square. And so the square's 4th side is also the diameter of our circle. But that means we don't know the length of this curved side here. And that's going to be part of the perimeter, right? It's part of the outside of the shape. So the first thing we need to do is we need to figure out the length of that curved edge. Since it's a circle and we're trying to find out the length around the outside of the circle, we're going to start with the formula for circumference. Circumference is pi times the diameter. Now you also have a formula for circumference that says it's 2 times pi times the radius. But this first one that I wrote down is a little bit simpler, and it also uses the diameter, which we know. So let's use this one. So the circumference around a whole circle with a diameter of 6 would be 3.14 times 6 meters. And that's going to be 18.84 meters. But we don't actually want to know the distance around a whole circle. We want the distance around this semicircle, this half circle. So the semicircle, we'll take that 18.84 and we will cut it in half. Which gives us 9.42 meters. So that green edge there, that curved side, is 9.42 meters long. Okay, and now we're ready to calculate the perimeter. So it's going to be 6 plus 6 plus 6, or 3 times 6, plus 9.42. which gives me altogether 27.42 meters. And now we need to follow this last piece of directions here, round your answer to the nearest tenth. So which digit of this number is in the 10th place? The 4 is in the 10th place, which means we look to the 2 to help us make a decision. Should we round up or should we round down? Since it's a 2, we're going to round down to 27.4 meters. So the perimeter of this shape here is approximately 27.4 meters. All right, everybody, thank you so much for joining me in this lesson here. Make sure you give your homework on Google Classroom a try, and I will see you all again very soon. Take care.